All right, so let's get a little number line going, and let's make sure that we get the numbers that we're looking for. So 1, 5, and 8 looks like. So 1, 5, and 8. Make sure they're far enough apart from each other so that I can have room to work, because I really didn't need this much of the x-axis over here. All right, so I would encourage you to get these two increasing, decreasing ideas first. So this is saying that the function is decreasing, right? Derivative is less than 0, between -1 or negative infinity and 1. So going down. And it doesn't matter where you put it. You could have put it up here going down, right? It doesn't matter. So I'm just going to put it here. Then between 5 and 8 is going down as well. And then after 8. So here I know that it's going to be increasing between 1 and 5. So I've got the basic up and down going on the graph. All right. So now that would be what I would do first. The second thing is that I would put in what kind of critical numbers I've got here. So at 1, the derivative is equal to 0, so that means it's a nice bottom of a parabola. At 5, the derivative doesn't exist, so I'm going to put a pointy thing right there, and we'll be enhancing the graph, and kind of you have to do this with a pencil and a little bit of erasures. And then at 8, the slope is 0. So I'm thinking something like this, and then coming down. So again, lots of erasing, lots of pencil, enhancing. Okay, so now these two will tell us about the shape of the graph. Second derivative positive says it's cupped up. So it's cupped up between negative infinity and 5. So all the way to here and all the way back here. So it matches. I'm just going to get rid of some extra lines here. So it matches that the bottom here is slope 0 at 1. And it's cupped up. Okay, it's also cupped up from 5 until 8. So I'm just going to make it a little more cupped up from what I had drawn initially. So again, that's why you want to do these in pencils. So it's cupped up to here. And then here, it's cupped down. So this is cupped down like this. And make it a little more cupped down looking. So there we go. So that's our graph using the pieces of information given. Okay, so another type of problem you could be given is I'm giving you what the derivative is equal to. Wouldn't want you to find the antiderivative, but I'm telling you the function is continuous for all reals. So any x value could be a critical number. So I know that the derivative will equal 0, where the numerator is equal to 0, so that's 3. And the derivative doesn't exist, where the derivative has a 0 in the denominator, so that's going to be at x equals 0 and at x equals 5. Okay, so now to find out if I have a local max or min, I'm going to have to check x values on the derivative between these critical numbers. So here's 0, 3, and 5. So the derivative doesn't exist at 0, so that actually means there's like an asymptote at 0 and 5 on the derivative graph, and at 3, the derivative is equal to 0. So I still need to check values before 0, between 0 and 3, between 3 and 5, and then after 5. So I'm looking to find out if it's just positive or negative. So let's just go plug in -1. And I'm not going to figure out numbers. I'm just going to be evaluating this derivative at -1. So I put in -1 in the numerator, I get positive. Then I would get negative out of the cube root. And I would get a positive out of the 5 minus plus 1 to the 2/3. So all told, this gives me a negative number. So there's negative before 0. So I'm going to do the same thing for 1. So I get a positive in the numerator, a positive, and a positive. So it's above the x-axis. So all of this gives me a positive. I'm going to try 4 into the derivative. So 3 minus 4 is negative in the numerator. Positive, positive. So all of this gives me a negative. And then I'm plugging in a number like 6 into the derivative. So I get a negative in the numerator, a positive, and a positive. So it's still negative. Okay, so using these pieces of information, what do I see? I see between, or I'm sorry, on the either side of 0, the derivative is changing from negative to positive. So let me write this up here. So I would say at x equals 0, the derivative f prime changes from negative to positive, so therefore f of 0 is a local minimum. So since the derivative doesn't exist on the graph of the function, it might be a cusp. All right, so then at x equals 3, f prime changes from positive to negative, so therefore f of 3 must be a local maximum. And then here on either side of 5, the derivative stays negative, so it's neither a max or a min. So I don't need to go and figure to make a statement about that.